Anusha. In this video, I would explore the topic Recursive CTE of SQL. A recursive CTE is a query that repeatedly references itself to process hierarchical or sequential data until no more rows can be written. It's useful for working with hierarchies, generating sequential data, and checking for data gaps. Let us look at each purpose with the use cases. Here I have an employees table where I have employee ID, name, and the manager ID of that respective employee. So we are finding the hierarchy of employees under a given manager. So here I have written a recursive employee hierarchy where the manager ID is null. I have started with manager ID is null because Max has no manager ID. That implies that Max is at the top position of the organization. And I have joined the employee hierarchy table and the base employees table with this condition. The employee ID of the hierarchy table is equal to the manager ID of the base employee table. And here we're getting levels, Max at the top position, Joanna and Leah at the second position, and all the others come under the third position. And here I have the same query. I have tried to get their manager name so that it feels more intuitive. So here for that I have given manager name. If I directly use null, that it will take the character values very less. That is the reason I cached it here. And then I selected manager name with this condition. So this is how I am getting the Max has no manager, Joanna and Leah's manager is Max, which are at this level, and Alex manager is Joanna, and all the other employees manager is Leah. And here we are calculating the hierarchy of managers under a given employee. In the previous queries, we are finding hierarchy of employees under a given manager, but here we are finding hierarchy of managers under a given employee. So here we selected an employee Mary, and with Mary, when we have given this condition, like in hierarchy table, we are fetching the manager ID and making equal it to base employee ID. So this is how the hierarchy goes. Mary's manager ID is 5, that is Leah, and Leah's manager ID is 7, that is Max, and Max has no manager ID, so we have come out of loop. And next, working with hierarchies, we look at the family tree example also. So here I have a family table where I have person ID, person name, parent ID and relation. So the grandparent doesn't have a parent ID. So here the hierarchy stops at that level. So here to find the relation depth of a person in a family hierarchy, again we are writing the same query. In the family hierarchy, we are starting with parent ID is null, and then we are recursively finding the persons with the level. We are incrementing each person's level with respect to this condition. And here you can see grandparent at 1, parents at 2, and child at 3. And next, to find all ancestors of a given person, I have selected Olivia. In the previous example in employees, we have selected Mary. In the same way, we are selecting Olivia. And Olivia parent ID is 5, that is Peter. And Peter's parent ID is 2, that is Mary. And Mary is the grandparent. Now, if we really want to understand a business use case, I have selected the bill of materials where I want the levels for the items. So we have in this table, we have selected like item name is bicycle, which comes under the top parent ID. And this frame, wheel, handlebar, tire, spoke, rim, all these parts come under bicycle. But here again frame, wheel and handlebar are parts of their own, so they will have their own level. And then tire, spoke and rim come under the wheel category. So wheel is 3, so we are having the parent ID 3. But this is confusing, so we will be writing an recursive CTE query so that we'll get levels for each part of bicycle. So we have written in the same way, we have started with parent ID equal to null, and then we have recursively incremented the levels with this condition. And the next use case is we can generate sequential data or series with the recursive CTE. So this goes like this. So we are select 1 as n. With that we are starting n equal to 1 value, and then we are incrementing n plus 1 for every iteration. Here notice 10 is printed, though we are giving n less than 10, because before coming to this condition the n is being incremented already. So what is the use of generating data series for a data analyst? So for that, like analysts often need to generate range of dates, numbers, especially if the data table doesn't have a date dimension table. But here we'll see, like this is the sales table I have. For in the October I have the sales date for 1st, 3rd, 5th and 7th, that to 1st to 7th October. So if a manager wants to see daily sales report, if we just select group by dates, this is the kind of output we are getting. But here we need to understand that the days where there are no transactions are not even displayed. So to fill that gap, we have used recursive dates, where in this query we are generating all the series of dates from 1st October to 7th October, and then we are using college, where if there is a sales amount, display that, or else display 0 as total sales. So here we can see in which we can even see, the manager can even see the days where there are no sales. In the same way, if you want to detect missing invoice numbers, see, we have this kind of invoice table, and we want to detect invoices. So with recursive sequence, we are generating invoices from 1001 to 1009, just like this. But then again, we are counting which invoice is null. So then with this condition, when we are cross-checking with the sequence table, we are these invoice IDs which are null are displayed. So in this way we can find missing invoice numbers. Next, in the use case of generating sequential data or series, now here we have actuals table, actual sales amount for these dates from 1st to April of 2025, and here we have forecast table where from 1st to June of 2025. So now what we are doing is, we are trying to calculate the variance. So how we are calculating? First, with recursive months, we are generating all the series of months from 1st January to 1st December. And then we are displaying data as for actual sales. If actual sales is there, it is that, or else it would be displayed as 0. If actual sales amount is there, then it would be displayed here. If there is only forecast amount, because that actual sales has, that time has not come already, or it is not recorded, then forecast amount will be there, or else it would be 0. Just in the case here we are getting forecast amount, but if both are not present, then it would be 0. So here we are calculating the variance, and this is the variance amount. This is very useful for financial analysts or supply chain analysts. Thank you.